Hello there. Welcome to Science for High School with Merivit Education Center. The series is for M.2. I am Master Rick, and today we are going to learn about energy. We're going to define what energy is, and we are also going to look at the forms of energy. Now, if you're ready to go on that journey of knowledge with me, then come along. So, what is energy? Now, energy is defined as the ability to do work. Work is just the transfer of energy that happens when an external force moves an object. Energy is a conserved quantity. Now, what is very peculiar and what is very interesting about energy is that, according to the law of conservation of energy, it states that energy can be converted in form but not created nor destroyed.
The energy acquired by the objects upon which work is done is known as mechanical energy. Mechanical energy is the sum of the kinetic and potential energy. The principle of conservation of mechanical energy states that if an isolated system is subject only to conservative forces, then the mechanical energy is constant. Potential energy is the energy stored in an object due to its position. The stored energy depends upon the relative position of various parts of a system. Gravitational potential energy is energy that is held in a vertical position due to the force of gravity working to pull it down. Now, the amount of gravitational potential energy an object has depends on the height and its mass. The heavier the object is and the higher it is above the ground, the more gravitational potential energy holds. Gravitational potential energy increases as weight and height increases.
Now, let's look into the equation for gravitational potential energy. Now, the change in gravitational potential energy, which is delta PE, is mathematically explained through the equation delta PE sub g is equal to m times h times g. Now, with h being the increase in height and g the acceleration due to gravity. Now, to determine the gravitational potential energy of an object, a zero height position must first be arbitrarily assigned.
Elastic potential energy stored as a result of the deformation of an elastic object, such as the stretching of a spring. Now it is equal to the work done to stretch the spring, which depends also upon the spring constant K as well as the distance stretched. The kinetic energy of an object is the energy it possesses due to its motion. Now, it is defined as the work needed to accelerate a body of a given mass from rest to its stated velocity. Having gained this energy during its acceleration, the body maintains this kinetic energy unless its speed changes. There are many forms of kinetic energy: vibrational, rotational, and translational. Kinetic energy is a scalar quantity. It does not have direction. The kinetic energy of an object is completely described by magnitude alone.
Kinetic energy is proportional to the mass and proportional to the square of the velocity of an object, shown here in the equation Ke is equal to 1 half mv squared. The constant of proportionality turns to be 1 half. Now, since kinetic energy is not a vector, in squaring the velocity vector, which is v, we lose its directional part. So Ke, or kinetic energy, is a scalar quantity, and there is no direction.
Now here are sample problems to illustrate the types of energy.
Now, here is problem number one on calculation of potential energy. We have a cart that is loaded with bricks and pulled at a constant speed along an inclined plane to the height of a seat top. If the mass of the loaded cart is 3 kilograms and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart at the height of the seat top? Now, in this problem, we need to calculate the potential energy of the loaded cart that has a mass of 3 kilograms and a height of 0.45 meters. Now, to get the potential energy, we need to use the equation potential energy is equal to the mass times the acceleration due to gravity times the height. Now, plug in those values and you will get I will give you a few seconds to think about the answer. And when you're ready, I will give you the answer later on. All right. Do you have the same answer as mine? Is your answer 13.2 joules? Very good. Now here is problem number 2 for calculation of kinetic energy. Determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meters per second, and that is very fast. Problem number 2 is that kinetic energy of a 625 kilogram roller coaster moving with a speed of 18.3 meters per second. Now, to calculate the KE or kinetic energy, it would be 1/2 times the mass times the square of the object's velocity, wherein it is equal to zero point 0.5 times the mass of 625 and the square of its velocity, which is 18.3. Therefore, the kinetic energy is not yet. I'm going to give you a few seconds to think about the answer, right? Calculate. And later on, we will give that to you. Do you have the answer already? Is your answer the same as mine? Is it 1.05 times 10 raised to the power of 5 joules? Then if it is, good job. And that's it, boys and girls, for our discussion of energy and forms of energy. I'm going to see you again in the next episodes. Don't forget, just like the immortals of science, Einstein, Newton, and the others, remember always, science is cool.